All right, guys, last topic to talk about in our special lines and triangles chapter is another triangle inequality theorem, kind of like the last one, although the last one just deals with one triangle at a time, and this one deals with two triangles at a time. So when you're dealing with two triangles at a time, we kind of name the theorem differently. This is speaking about one triangle, and the Hinge theorem and its converse, which is just the reverse of it. So like if then becomes like if then swapped. So if you guys remember back to that, we'll do that on page 62. This is an inequality in two triangles. Although I don't think it's any harder. I mean, it's different, but it's not too much harder. So it has a lot to do with, so if we turn to 62, it has a lot to do with the whole like matching up opposites. So like if I find the smallest angle, across from that is the smallest side and vice versa. So that's really what the Hinge theorem and its converse are saying. So if we start with the Hinge theorem first, the Hinge theorem says if CA is congruent to FD, so here and here, and maybe put some tick marks on there so we remember, and CB is congruent to FE, and I know something about the angles in between. So this last thing right here is saying that the measure of angle C is greater than the measure of angle F. So like, for example, it doesn't have to be these numbers, but just to give you some sort of context, if angle C was like 50 degrees and then angle F was 40 degrees, angle C is greater than angle F. So you kind of have to have a side angle side thing going on. You need to know that the two sides surrounding the angle in question, you need to know that those two sides are congruent. And then what you can do is you can make a guess, although it's not really a guess because the theorem is proven it's true, about the sides opposite. So if I go to the side opposite of C and the side opposite of F, then a similar thing will be true about them. So because angle C is bigger than angle F, this side AB will be greater than this side DE. I don't know exactly how much greater, but still greater. And that's like some information. So that's kind of interesting. So if we take a look inside, this first example is the most obvious because I have a side angle side thing going on, and I can see that angle B is bigger than angle F. I already know that. A new piece of information that you could say is that this side opposite of B, AC, is greater than the side opposite of F, DE. Now, it wouldn't really be wrong to say the complete opposite of that either. You could also say that DE is smaller than AC, and that would be true as well, like we just reversed it. Now we can do a similar thing over here. This picture is just a little bit funkier. So I can see that JK is the same length as JM. And then this line kind of going in the middle here, not right in the middle, is shared on both triangles. So it is congruent to itself by that reflexive property. And so based on these angles in between, because 40 is bigger than 25, I know that the side opposite of 40, KL, will be greater than the side opposite of 25, LM. Or again, I could say the complete reverse of that. LM will be smaller than KL. So like not too mathy, it's just showing that stuff is bigger. Now we can also say the converse of that. So the converse of that, again, has a side angle side thing going on. So let's make sure I do this in the same color. CA is congruent to FD, just to be consistent. Boop, boop. And CB is congruent to FE. So I still know that two of the sides are the same length. But this time, the additional information that I have is about the side lengths. So they're kind of telling me that AB is bigger or longer than DE. So again, to give it some context, like maybe I know that this side length here is 10 units long, and this side length here is 9 units long. I know that they're bigger, but the new piece of information that I can get is if I go opposite, then I could say angle C is greater than angle F, or the measure of. Okay, so it's literally the opposite of that. Like here I knew the angle, so I said about the side. Here I knew about the side, so I said something about the angle. So again, if we open this up, I can see, comparing these two triangles here, that the 15s are the same length and the 25s are the same length, but the other two are not. This side is greater than that one, which you don't need to tell me, I already know. But what you could tell me that I don't know yet is that the angle opposite of that, angle C, will be greater than angle F, because the 35 is bigger than the 30. Or you could say the flip of it, angle F is smaller than angle C. And then similarly on this picture here, we kind of get a similar example. So I can see that these two sides are the same. They're showing me with the tick marks. And then the triangle shares this side JL on both triangles. And so this is kind of the angle in question. I don't know how much it is, but if I go to the sides opposite, I'll be able to know a little bit. Because JM is longer, this angle, angle MLJ, will be bigger than this side, or this angle rather, across from this side, which is shorter. So angle KLJ. Or again, you can say the flip of it. Now this is helpful because it allows me to write some ranges of values. Because I know the Hinge theorem and its converse, in this picture here, I can see that these sides are the same and it's sharing this reflexive side here. And I can see that this angle is greater than the 70. So I don't really need to say like 80 is greater than 70, like I get that. But since 80 is greater than 70, x plus 5, the side across from 80, will be greater than 18. And then I can solve for x and see that x will have to be greater than 13. Now, kind of a sneaky thing here is that like x also has to be bigger than 0. So I have to like set this equal to 0 and say that x has to be, oh no, never mind, not on this one. Forget what I said. This one over here is the converse theorem of that. So I don't know about the angles, but I do know about the sides. And so since 6.3 is greater than 4, I can say that 60 is greater than x plus 5. And I can solve for x by subtracting the 5. And so we'll have 55 is greater than x. Now this one is where we also have to make sure that x stays bigger than 0. I didn't need to worry about it here because x has to be bigger than 13, which is already bigger than 0. But on this one, because x is smaller than 55, I also have to make sure that it stays above 0. So whatever your x equal equation is, so x plus 5, I have to set that equal to 0 and make sure that it stays bigger than that. So if I subtract the 5, I can see that x also has to be bigger than negative 5, which I know feels a little weird, but if I have x equal negative 4 and plug it in, I get an angle of 1, and that's fine. Like it could be 1. So you just have to make sure that you're staying bigger than 0, which I know is a little funky. So let's try a couple more. So with this one here, I can see that these angles can be compared, where this one is larger. So I'm going to say 5x minus 8 is greater than 30. And so if I add the 8 and divide by 5, it's not going to be pretty. I'm going to leave it as 38 over 5. But since x is getting bigger than that, I don't need to worry about it potentially becoming 0. So that's all done. On this one, we have our side angle side stuff. I already know about the angles, so I'm going to go to the sides opposite. So x plus 4, because it relates to the 70, is going to be greater than 15, because 65 is smaller. I subtract the 4, and x will need to be bigger than 11. So since x is bigger than 11, it'll never have the potential to be 0, so we don't need to worry about that. We go over here, we know the sides can be compared, and this one is larger, so 70 has to be larger than this 8.51, which is 2x minus 5. So if I add the 5 both sides, I get 75, and then divide the 2, if not pretty. So x is going to be smaller than 75 over 2. So since x is getting smaller, I do have to make sure that it stays above 0. So if I take that 2x minus 5 equation and say, okay, you got to be bigger than 0 though, I would add the 5 and then divide the 2. So x also has to stay bigger than 5 over 2. And then last but not least, I know about the angles, so I can compare the sides. And the 70 is larger, so 17 will be larger than 3x plus 2. And because the x is on the smaller side, I have to keep it greater than 0, which I can throw that in there right now if I want. Maybe you guys remember doing these from last year. Whatever I do in the middle to x, I have to do on both sides. So I subtract the 2 everywhere. So we'd have 15 is greater than 3x, which is greater than negative 2. And then divide the 3 everywhere. And so 5 is greater than x, which is greater than negative 2/3. Which feels really strange to do, but that will keep it above 0, because if I plug that in, I'll get exactly 0. So if I go a little bit bigger than that, then I won't be 0. Hopefully that doesn't seem too confusing or weird. But if you have any questions, come to our drop-in, let me know.